Hello, Matt Davis here with more homework quiz help. This one comes from section 3.4. At one point during the ESPN broadcast of the 2010 World Series of Poker main event, the remaining ages of the 366 remaining players were shown in group form. We will use that data that's shown below to summarize the ages of the remaining 366 players. And we've got that table organizing the age ranges and the frequency of those age ranges. We've got a sum of the x squareds, and they want us to find what percentage of the data values lie within 2 standard deviations of the mean. Round our answer using 2 decimal places, and don't type the percentage symbol in the box. All right, so there's a lot to get to, but the first thing we're going to do is make a change. I'm going to reduce the sample size by 1. I'm going to take the one person that was in their 70s and say, sorry to them, but you're out of the tournament. I'm going to remove them. So that means that instead of 366 remaining players, we have 365. So make that change in these 2 spots as well. And it says it here, so we'll change that one. So we're going to work with 365 players, just assuming that oldest player has just busted out of the tournament, and now we're down to what we have here. So all the work's going to be the same, but it's going to change the answers. All right, so there's a few things we have to do. If we're going to calculate what percentage lie within 2 standard deviations of the mean, and by the way, we're not going to do that. We're going to change that too. We're going to make it 2.5 standard deviation of the mean. But if we're going to do that, we need to know the standard deviation and the mean. And if we need the standard deviation and the mean, we need to know what type. And those 3 issues are the questions that preceded this one. So one of those previous questions is, what kind of symbols would you use if you were trying to get the mean and standard deviation for this situation? The key to that is that we're just going to use the data below to summarize the ages of the remaining 365 players. That's telling us that the 365 players are our population of interest, and that means that the mean that we want is going to be mu, and the standard deviation that we want is going to be sigma. So those are the symbols that we're looking for. And then on the previous problems, when it asks for the mean and standard deviation, it says we can use technology. So what we're going to want to do is do stat, calc, and even though we have ages and frequencies, we're still going to choose one variable, statistics. But we do need to use the ages and the frequencies. So we're going to put the ages into L1 and the frequencies into L2. So we need to start out by thinking about how that's going to work. The ages are our x values, but the ages are ranges. So what do you do when that's the case? So the answer to that is you get an x column, which is represented by the midpoint. So halfway between 30 and 40 is 35. Halfway between 40 and 40 and 50 is 45. Halfway between 50 and 60 is 55, and halfway between 60 and 70 is 65. So you would think the one at top would be 25, but that range isn't from 20 to 30. It's 21 to 30 because you have to be 21 years old to play in the World Series of Poker in Las Vegas. So we need to average 21 and 30, which is add those 2 together, divide by 2, and it'll give us the number in the middle. I'm going to skip showing the work, but that ends up being 25.5. And it is important that you have that one accurate, otherwise it's going to mess everything else up. So what we're going to do is take those x values, which represent the age, put them in L1, and these frequencies we're going to put in L2, and then that's going to allow us to do this one variable stats L1, L2. So let's go get that work done, and then we'll come back and tackle the rest of the question. So switching to the calculator, we're going to hit stat, we're going to hit edit, and we'd want to enter those x values, which are the midpoints, into L1. I've done that already. We want to enter the frequencies into L2, and I've done that already. The next question, or the next step, is to have the calculator do the calculations for us. So we're going to hit the stat key, the calc menu up top in the middle, one variable statistics. Sometimes that confuses people because we have 2 columns. They think we should do 2 variable statistics, but our only variable here is age. Frequency is not a variable. It's just helping us count the occurrences of the age variable. And so then, even though it's one variable statistics, we have to give it all the information. The age representative values in L1 but also the frequency with which those occur, which are in L2. Make sure you get the comma in there. If you don't do that, that can mess it up too. One of the things you would generally want to check is the sum of the x squareds and make sure it matches the number they gave you. This one does not match because we got rid of the 70-year-old from our table, so that changed the data set. But if you had them in there, it would match. So make sure you're checking that sigma x squared as a match. If it doesn't match, something's gone wrong. You shouldn't keep going forward. You should find your mistake. Could be that you forgot the L1 comma L2. Could be that you did two variable stats. Could be that you had a typo, but go look for it and find it. All right, so this is population data. So even though they call the mean x bar, if we know it's population data, we have to rename it as mu. So our mu is 32.43, sticking with the 3 because the digit after it is a 1. And then they give both a sample and population standard deviation, but we know this is population data, so we'll use sigma 9.5075 followed by a 0, so we'll stick with the 5. So let's go back and write those numbers down. So for the mean to 2 decimal places, which is what they asked us for in the previous problems, I believe, we'll put 32.43. For the standard deviation of the population, they asked for 5 significant figures, so 9.5075. So there's all the previous problems work done. We figured out what symbols to use, mu and sigma, and we got the mean and standard deviation. Now on to the actual task that they asked us to do here, which is calculate what percentage of the data values lie within 2.5 standard deviations of the mean. Some versions of your problem will say 2, some will say 3, and whichever one it is, just follow that pattern, but substitute the 2.5 for your number. So I'm going to do mu plus or minus 2.5 times sigma. The mu is 32.43 plus or minus 2.5 times the sigma, which is 9.5075. I'm going to do that with a minus, and I'm going to do that with a plus, and that's going to give me boundaries for how far you have to be away for the mean to be 2.5 standard deviations away. So back to the calculator, clear this stuff out, type in our mean, 32.43, subtract 2.5 times the standard deviation, 9.5075, press enter. That's our lower boundary. If I hit second and enter, it pulls that last calculation back up. So instead of retyping it, I can arrow over to the minus and change it to a plus. Press enter and get my upper boundary. So there's the two boundaries that we need to work with, 8.66 and 56.20. So let me write those down. 8.66 and 56.20. The rounding isn't that important, like in terms of how many decimals you put here. We just need to make sure we're only counting things that fit between 8.66 and 56.20. We're talking about ages here, so to fit in between this one and this one, you have to be older than 8.66. Everybody in the tournament is, but specifically, all these guys are. But do I highlight them all? No, because the upper limit is 56.20. And so I would highlight the 55 because that's in between 8.66 and 56.20, but I would not highlight the 65. So we have only the people above that red line that we want to count. Often there's a boundary at the top too, but in this case, the boundary was so small that nobody was beyond it. So we want to count all the people whose ages are in yellow, which means we want to count how many times that occurred. Make sure you don't count that it was 4 rows out of 5. Count how many people it was out of 365. So the fast way to count it, you could add up those 4 numbers I just highlighted, but really what we want is everybody except for the 5 people that were in their 60s. So when we go to calculate this percentage, we could say we want all 365 of the people in the table except for those 5. And if you add the other 4, you'll get the same thing. And then divide by 365. Put parentheses around that if you're going to do it that way in the calculator. And then let's go to the calculator and see what we get. So 365 minus the 5 people we don't want, divided by the 365 in the table, gives 0.9863. The 3 is followed by a 0, so we do not round up. 0.9863. So 0.9863. This confuses people sometimes. I put 4 decimals and they said they want 2, but they want 2 on the answer, and this is not our answer. The percentage is the answer. So by putting 4, I've made it so that when I multiply by 100%, I get 98.63%, which now this is my answer, and my answer has 2 decimal places on it. If I was just doing this on a test, this is the answer I would give, because I'm doing it on active learning, and they said, do not type in the percentage. I'm going to leave that off in the box and just write 98.63. All right, so there it is. That's the process. We did a lot. Where are some of the places that it can go wrong? Putting 25 for that first midpoint would throw everything off, so that's something to watch out for. Counting 4 rows out of 5 instead of 360 people out of 365 is a spot it can go wrong. Forgetting to put both the L1 and the L2, or using one variable statistics, either of those. So make sure you remember that it's one variable and that you get both the L1 and the L2. And anything else? That last part too. So they want 2 decimals on our answer, so because of that, sometimes people will just put 98% or 99%, but it's 2 decimals on the answer, not on the initial decimal. So I put extra decimals right here so that I would still have 2 on my answer. All right, I hope somewhere in there you found the spot that was giving you trouble. Good luck to you as you head back to the quiz.